All right, well, let's get started here. Let me share my screen. Right. Okay. Yeah, Terry. Okay. So what we've got here is the auction app we worked on last week. I think it's a slightly changed, but basically the same thing. And what I want to do is over the next few sessions, or we may do some and then we may take a break. But what I'd eventually like to do is build this out into more of a real application. And my goal would be by the time we are done with this, there is some public URL that you can go to that is a logical, normal URL, is whatever xyzauction.com, and you can interact with this thing. And you can pick different auctions and you pick items, and it's kind of like at least a poor man's eBay functionality. And clearly last time, I think we had like a concept of it, but what we had is not gonna scale up as we wrote it to kind of being the scale of eBay, which makes sense because we had an hour and we were also just talking about the concepts of all this stuff. But the idea is to build up to that over time. And I think there's some stuff we'll just do. And then there may be some places where we say, hey, we really need some more functionality from Golem for this thing. And we'll have a little bit of a race between our Zymposiums and our development efforts of if we kind of deliver those things on time, or if we kind of have to take a break, and we'll cover some things other than Golem and Zymposium, and then we'll kind of come back and add some additional features. But for today, I wanted to focus on kind of three things for us. So one is I wanted to show you how to get better output from VS Code. This will be kind of a super simple one, but I think a really tactical one that will, if you're not already doing it, like just want to give you the tip there. Two is I want to look at refactoring our data model and best practices there. So one of the things we did last time is we essentially reused all of these WIT types in our business logic here, right? So like these item IDs we're working with, all these items, all these things are being generated by out of this WIT file. But I think there are actually some disadvantages with doing that, and I think that's probably not the best practice. So I want to walk us through a little bit why I think that is, and kind of suggest an alternative. And we'll do some refactoring there, and I think that'll actually probably take a decent amount of our time today between these two, just kind of doing that refactoring. And I think in the process will. If you haven't seen Rust, you'll see more Rust and you'll see more of that. So depending on how you feel about Rust, that may be a good or a bad thing. And then the third thing is we want to refactor our app to use multiple workers. And I think this one, depending on timing, we may get to start this. I think we're definitely not going to finish it, and there's going to be some architecture work of like how we want to set those up and setting up those interfaces, and then there's going to be some implementation work of like, okay, actually having the right people interact with each other in the ways we set out. And I think what we'll get to today will probably be more the architecture of it than like the implementation of it. But that's kind of the goal for today. If you're not already on there, I think just about everyone is, but check out the Discord to comment on what we're doing here, and I'll try to check that. This is more of like a normal Zymposium versus the last one was a little bit of like a special event. So last time I had some of my colleagues who were kind of there to like jump in and like answer questions or feed questions to me. This time it's just me. So I've got an iPad over here. I'll try to turn to periodically to check, but if there's a little bit of delay, that's just why, and I'm not trying to ignore you or anything. Okay, so let's look at this. And so this first topic is how we get this better output from VS Code. And one of the things you might have noticed last time when I was doing this is I was at a different computer, so I had it set up, but I was getting a lot of squigglies here in VS Code, where essentially the IDE didn't know about these types that came from this WIT file. And so when I actually did my cargo component check, everything worked fine. But when I looked in the IDE, I had these squigglies and I wasn't getting the same level of like autocomplete and suggestions and types here that I like. So that's not the most lovely thing. And that's actually a really easily solvable problem. And the way you do that is you go to your settings, and then I'm just going to search for environment Rust. And there's this one called Rust Analyzer Server Extra ENV. And so I just go in here, and there's just this basically little bit of extra code. I don't know why it's formatted somewhat weirdly right now, but weird formatting or not, it works correctly. And this basically tells the Rust analyzer here, right, its server, that it should also use this cargo component, which is going to allow it to have visibility into the component model, into the WIT file, and all this stuff that cargo, which is just a basic build tool for Rust, doesn't know about. It doesn't know about WASM or WIT or any of these things, but cargo component does. So when we bring that in, and we can just set that, like I have it here set globally for VS Code now. So just for all time when I'm working on something, I'll have access to this if I need it. I think most of the rest of the time we'll just kind of sit around and do nothing. But that's like a really nice thing. And that's in the like shopping cart example in the template now, at least for that particular project. So I would probably do it globally, but that'll at least have it in that project. So you have like the kind of incantation that you need to do that. I see Juan had a question about recommended Rust references. There's a book I did. I think it's kind of the like one of the just basic ones. I don't remember the name off the top of my head. I'll post it in the Discord after this. Also, I guess a little bit of bias disclosure, but John Arcia did a really nice workshop on Rust, particularly if you're coming from a Scala or Java background, but kind of for everyone as well. So that's another thing that I'd really recommend checking out if you can. I think that's not free, but if you can, that's a really good resource. Okay, so I think that one was, again, quick, tactical, but you can see here now, like I've got all my types. I've got like inferred types here. And I also have like really, instead of garbage problems, I have really specific problems, which is here, like I just accidentally have these unused variables. So I'll just comment those out, and now my ID will be happy. So not rocket science all, but if you're actually doing this, it's really nice. So I wanted to make sure that you saw that if you weren't already doing that. Okay, so if you have any questions on that, just jump in and I'll be checking, but seems like no one does. So I'm just gonna kind of go to the next thing here. And so this next thing really gets to like this WIT file and what it is and how we use it. And I think a bunch of people even just got confused about like, what's the deal with this WIT thing and like, why do we need it? And I think afterwards I realized, I think a really good analogy for it is it's the protobuf of this ecosystem. So if we look at this file, I mean, again, if we kind of say modulo the fact that like it has slightly different syntax than a protobuf file would, it's actually conceptually really similar, right? Where like this, if we think about like in a protobuf file, we would like define our interfaces, right? And we'd say like, oh, you can call it with these 5 things, and each one takes some types and returns a type, right? I mean, this is, again, written slightly differently, but this is conceptually just like a protobuf interface. And then we get to define some other types that are basically just like data types, right? We can have kind of records and enums, and we can put them together. And that's really all this is. So I would think about this as just like the protobuf of this ecosystem. And I think at least a better protobuf from a developer perspective. There are some things about protobuf where, like, with some exceptions, like everything's like maybe nullable or optional. And there's a reason for that. But I think from a developer perspective, it's like then annoying to use it because you always have these possibilities that you really shouldn't exist if you're doing things correctly. And again, maybe very efficient in things, but I think this is a nicer interface to work with. So it's nice that we get to work with it. And I think that's maybe just a helpful analogy because I think gRPC is something that people use pretty broadly. Protobuf is probably something that you've used or come across or read about at some point. So I think it kind of demystifies this a lot, that like it's just a different syntax for like a protobuf type thing. And you can see it's like a little bit, I mean, definitely when I do this, sometimes I screw myself up and I do like underscore instead of dash or whatever, but like there's nothing that like special about the syntax. So I think if you kind of see one of these files, and you can pretty easily copy it for whatever you need. I think the other thing that I like about the protobuf analogy is that we probably all use protobuf a lot, and we have existing kind of practices around like how we use it, how we don't use it. We maybe have tooling that helps us with it, and maybe in some cases that can be an inspiration for tooling that we should have for dealing with these WIT files. But I think in particular, one of the things that, at least in my experience, you would typically say is you wouldn't actually use your protobuf data types in your quote unquote business logic. And I think maybe part of that is the protobuf itself is, like we talked about, like things are kind of nullable all the time, that like that's not ideal. But I think even aside from that, and probably the exact trade-offs depend on the language that you're in, but having these like auto-generated types that are generated by a third party sometimes doesn't give you as much control over them, right? Of depending on what language you're in, maybe you want to implement special constructors for them that have different like validation rules for creating them. And also it just kind of ties the business logic to that external interface where if we need to maintain some type of compatibility, this kind of needs to be locked down, right? Maybe we can add more methods here, but this has to basically keep its signature into the future. Versus our internal logic, we might want to evolve in different ways. And so having those be the same creates this tight coupling that's not ideal. So at least what I've seen in code bases I've worked with is typically you have your protobuf types, which automatically get generated from the protobuf, or here we have our WIT types that automatically get generated from the WIT. And that's great, but what you basically do is as soon as something comes in, you translate it from the protobuf type into your own internal data model. You do everything with that internal data model, and at the very end, when you're ready to hand it back here, you turn it back from the internal data model into the protobuf type or into the WIT type here. So what I'm going to do is start to refactor this to do that. And I think that'll start to kind of clean up our code, create some separation, and eventually then these things are going to live in different modules, and we can even potentially extract the kind of all of our business logic into a different project or a sub-project here that doesn't depend on any RID or cargo or any of this stuff at all, or well, no, cargo, but not cargo component, excuse me. And so that'll be nice, because actually one thing that is, I think, a little bit of a wart with this cargo component now is if I want to write tests, if I do this cargo component test that doesn't exist, I can check, I can compile, I can create something, but I can't write tests with this. This is actually something that Harry opened a feature request for. So I think it'll be coming at some point, but it's not here today. And Damien asks what WIT is. So WIT stands for WebAssembly Interface Type. But again, the way I would think about it is it's just a different version of like a protobuf file. So it's a way of specifying the API or the spec for one of your workers, or ultimately one of your services. So like here, we're saying this auction thing exposes an API that basically has these 5 ways that you can call it. And then this is just kind of giving us more detail on what these data types are that are involved here. Does that make sense, Damien? Okay, awesome. So what I'm going to do here is I'm going to start by creating a new file. And hold on. And so Damien asks, is the WIT file Golem specific or a standard? It's definitely not Golem specific. It's a WebAssembly interface type. So it's developed and maintained by the same folks behind WebAssembly and the component model, but it's maybe when I'm not live broadcasting, I'll post a link to it. But it's a very public spec, and it's yeah, I think protobuf is like a way of thinking about it. It's not that exciting. It's, I think, a little bit nicer than protobuf, but right, you have records, you have variants or kind of their versions of enums, and you have functions here, but it's a limited kind of sub language. You don't have like subtyping or stuff like that. It's really just a way of defining your interface. Okay, so I'm going to call this other file model, which there's no magic to it. Just seems like as good a name as any. And then the first thing I'm going to do that's just a Rust thing is I'm going to do mod model. And I got my little card component check going here. And so this is kind of just the way that Rust does like packages if you're coming from like Java or Scala. So this is basically saying that this is going to be my like, quote unquote main file right now, but this is going to be able to access and depend on whatever I define in this model thing here. And I'll get to filling that in a second, but I think the next thing I'm going to do is I'm going to rename some of these types here because they've got all these like bidder IDs and items and stuff like that. And what I'd like to do is I just want to call those probably something like WIT bidder ID, WIT item, and so on, just so I can actually use like item and bidder ID and all these things for the business logic versions of mine, and I can keep track of which is which here. So to do that, I'm first going to change this from being a wildcard import to having these individual things and make sure I got the right individual things. I'm going to get rid of my extra brace here. Okay. And then I'm just going to start to rename these. And then I'm going to go through and take all these. And this will be this is some WIT item. Is WIT. And you can see why it's nice that now I've got the compiler helping me out here. Okay. Okay. So now that I've got that separated out a little bit more, I can start to define my own internal models of these different things. So here, let's do public struct. And what was our first one we had here? We had a bidder ID. So I'll have a bidder ID. And so right now, we could have it be a string, but this is like kind of another nice thing of having the separation of the internal versus the external, because really it's supposed to be a UUID, and I was just kind of encoding it as a string in the WIT file because it doesn't have its own native concept of a UUID, and I could have created my own record type that is a UUID, but I didn't. But here we can actually use the Rust UUID type. So we can say, okay, this bidder ID is going to be UUID. And then along with that, we can implement some I think this is right from oops. So let's grab these imports here. The API one. And okay, so this thing here, this from thing basically says I know how to create my data type from this other thing. So this says I can create an internal model of my bidder ID from the WIT version of the bidder ID. And you can see the COPI is actually really good at blowing through these data type conversions, which is great. And so the way I'm going to do this is I'm just going to look inside this WIT bidder ID, and it's got a string inside it, and I'm just going to parse that into a UUID. And right now I'm kind of going to say, well, I know that I'm the one constructing these, so they are always valid UUIDs. So this parsing is never going to fail. So I'm okay just basically unwrapping that and acknowledging that I'm going to panic or essentially throw an exception if you're in other languages if that parsing fails. And then I can also do a similar thing for what we call into. And let's see if, okay, it's just warnings. And so this just goes the other way. This says I can, if I have a bidder ID, I can turn it into a WIT bidder ID. And you can see I'm just going to do that by calling toString. And so this is, we're going to have to take a little while of just setting things up before we use this. But what this is going to do is going to make it really easy to essentially let me go back and forth between my business logic, my business types, and my WIT types. So imagine just it's called like toProto and front proto. And then I see Terry is, showing some like cheat sheets he's done and some resource he's found. So that's fantastic. Terry's been doing some really great work kind of creating some examples of these things. I think he was, I think he was one of the early people who kind of like to separate out the WIT types from your business logic types. So definitely credit to him there. And I'm sure we'll have him on at some point to kind of talk about, I think he's cooking up a new application. So maybe we will do that. Okay, so what we want to do is basically just go through and do the same thing for these other types. So let's look at these. So we have an item ID. So that I think is going to be quite similar. From into, I always think it's to instead of into, but it's not. Let's make sure this is still compiling. Yeah, we're good there. Okay, so we need bid results, items, and WIT items. So let's do bid results. And let's just go to the WIT and see, okay, so bid result is either a success or a failure. So let's in bid result. And the success, the failure has a string inside of it. And two into, so I'm already making a mistake. Okay, and then we just need deadline and item. Let's do deadline. And again, this is one where I think maybe we can be a little more strongly typed with this. So I think this is supposed to basically represent a duration in seconds since the epoch. So we should just be standard duration. Duration from with deadline. Okay. Into now I just have one last one, which is this item. Let's look at what the item is. Item, here. Okay, so it's got an item ID. Maybe I'll just copy this for a second. Okay, and so one thing I'm noticing here is the item ID was a string, which probably should be a item ID. So I'm going to make that change. And the rest of this looks fine. And I think to conform to that, I'm actually going to update my WIT file here. So I'm going to make this a item ID. And then that's going to flow through to my Rust file. I'm going to need to update my interface there. So here, I'll say oh, I see. So this is just the UID. This can be the item ID. And then we can return the item ID back here. And just, okay. So I'm back to compiling, and I just slightly cleaned up my WIT model here. All right, so now that I've got my item thing, again, I want my little converters. Yep, and 2. Okay, great. So now I've got business logic versions of each of my data types, and I've got ways to easily convert back and forth between them for each of these data types. So now what I want to do is I want to start extracting my logic out of each of these functions, where essentially what I want each of these functions to do is just call some function somewhere else that has like the actual business logic. And basically this function, all it does is it takes the input, it converts any WIT types into my business logic types, it calls the actual function, then it takes the result and it sends it back. So they, I think that's definitely something that we could look at doing. I think another potential thing to explore is just entirely automatically deriving the entire WIT file from, like in this case, a Rust data type. So you could imagine I kind of define a Rust data type with my interface and it just creates the WIT file from that. But yeah, I mean, already like this, like between Copilot and this automatic this functionality in Rust, it like blows through this pretty quickly. But yeah, you could definitely see having this have something that you have just like derive like WIT type or something for it. And I think we'll actually look at how we can derive other things with Rust later on. So yeah, that's a great point from Yuri. Hopefully I'm getting your name right there. And I thought, by the way, Yuri, you had some great tweets you were doing last week. So thank you for that. That was awesome. Okay, so I think what I'm going to do is I'm going to create another file, and maybe I'll call this auction logic. And so this is going to contain the like actual implementations of my functions here. So again, I'm going to go back to my main one here, and I'm going to add this as another module I'm depending on, so I can take advantage of this. And so we're basically going to want to take each of these functions that's in the API here, and we're going to want to create our own version of them. So let's start with this register bidder function here. And so I'm going to just bring in everything from my data model here. Oops, once. Yeah. Okay. And so the first thing I want to do is I want to get rid of any of these WIT types. So we can imagine this being just a bidder ID. And the other thing I want to do is I want to get rid of all this with state stuff, right? That's kind of a weirdness of like the fact that we want to use this global mutable state and this implementation here. And Rust doesn't really like that, but I want to make that very much like an implementation detail that's confined to this like one file and doesn't get into my logic anywhere. So at least the way I can do that in Rust is I could think about having some state type here. So basically this register bidder could take some state, and that could be like a mutable reference to the state we're modifying, and it could take this stuff. And then in addition to giving us back this bidder ID, it could update the state for that. So what I'm going to do to implement that is I'm going to create a new struct for this that I'm going to call the state. And I'm going to go back and I'm going to look at my existing state. And so before, what I had was this thing, which I'm just going to grab here, just so I can grab here, just so I can see it. And I think this is like a nice example of why, like you can see here, these were like raw UIDs versus these more strong types I had here. We had strings. And some of this was like because to go into like map, it's got to have instances of certain things of being equaled or being ordered or being hashed. And I had a hard time defining those because these types were auto-generated, or the WIT types were auto-generated. So I think here I can kind of have my own like more, and I also had this weird like lazy thing, which was like, again, I'm working on for like the Rust kind of global state. So I think I'm gonna have broadly the similar state, but I'm gonna get rid of the lazy stuff. And I'm gonna make this more strongly typed. So this bidders is, I believe, from bidder ID to, I think here I was only holding on to a couple of pieces of information about the bidder, but probably a better model is just for this to be basically a map from like the bidder IDs to the bidders themselves. This is a map to the item IDs to the items themselves. And then this, I believe, is a map from each item ID to the current winning bidder and the price they're paying right now. So now, I mean, with the exception of like this, maybe we could create a new type for this if we wanted to. This is now like much more like strongly typed. Oh, and I need a hash map. Okay, got my hash map. And then, okay, this just hasn't been updated. And let's see. Oh, so this is kind of a nice one here. So we had this string, and if we go back to what we had before, these two strings were supposed to represent the name and the address. And since we were just accepting them and we weren't creating a new type for them, there's not kind of a type that wraps these up together, but maybe that's another nice thing for us to do in our internal data model. So I could do something like struct bidder. And right now they've got a, yeah, maybe we should put the bidder ID in there just so we have it. And the name is in the description. Here's an address. Let's see what we did here. Yeah, and maybe this is a little bit anachronistic. Depends on whether these are like digital items or not, but we'll start with this. Okay, all right, so now this is like a nicely like strongly typed representation state. And now what we can do here is in my, my auction logic. So now I'm really in the position that I could say, okay, so in addition to taking a name and address, I'm going to take the state. And I'm going to take this thing, and I'll come back in a second and explain what that is. I'm going to get rid of this weird with state stuff. I'm just going to, okay. And let's see. Oh, so first thing, this is just a Rust thing, but all of these things are private by default. So at least, which is kind of good for encapsulation, but at least if we're doing stuff here where this is kind of the internal data model we want to use everywhere, then we want to make it public. And then let's kind of go through this logic and see how we can clean it up. So we're saying, hey, we got this new bidder wants to come in, participate in our auctions. They've got this name and address. So we want to create a new bidder ID for them. And then we want to basically put them in this table and then we want to return it. So I think first thing we could do here is we could kind of wrap some of this logic up back in our model here. If we've got our bidder ID, we could have a constructor for it, right? So we could do public function new. It's just going to generate the new UID. So now bidder ID is just going to be bidder ID. That it's nice. Then so here's another one of those ones where I just need to make these public. And again, there's a little bit of a trade-off of I could make less of this public and I could have more methods on the state thing. We could always go back and refactor that if we want to, but we're not going to worry about that right now. So I'm going to make a new bidder ID. Then in the bidders, I'm going to insert this bidder ID, and now this thing should be a bidder. So maybe I should make that. So I could say let bidder put this. And again, I could maybe have a constructor here, but I'm not going to worry about that right now. We can see here, because Rust is very careful with its memory, I need to clone this. So I can easily just use that to derive functionality. And so here, oops, extra new line there. I can just derive that. So I can do that. And then because I'm going to use this bidder ID as a key here, I need some additional properties on this thing, which is pretty easy for me to create or derive. So I can do hash. Let's do equal. Let's do partial equal. Let's do order and partial order. Okay, so then I'm going to insert a bidder here. And then here, I can just return back bidder ID. And then again, just because I put it into here. Oh, and then here, these fields are private. So why don't I actually, I'll just make this slightly nicer. Excuse me. Info bidder. No. Oh, this is. And now this can just be. And then our item, let's see. Let's look at our item. Okay. So we've now got a version of our business logic here that I would say now, maybe slightly other than just needing to clone some things for Rust is like super clean, right? This is just kind of our business logic here. And so let's do the same things for our other methods. And then we will refactor this to just kind of drop in our new implementations versus the existing ones. All right, so next one is we've got this like list item thing. So this is going to take a name, a description, a limit price, and it should take one of our deadlines, and it should return one of our item IDs. We don't need to do any of this funny business with state here. So let's see what we're doing here. So we are making a new item ID here, right? That's this logic. So let's, again, create a little helper for ourselves here. So we have the item ID here. And we're saying this deadline can't be found, which probably means we forgot to make it public. So let's see. Yep. Okay, so now this whole first thing can basically, I think, become let item ID equals item ID dot new. Then, so this function is going to need to take our state here, just like we did above. So then we'll say state.items.insert item ID and the item. Maybe we'll follow the same pattern here and just say let's create a new method for the item. So let's do item. Just to make it slightly nicer here. And then we want our item ID to have all those nice things that the bidder ID had. So those. And so now we'll just create an item ID, and then we could say let item equals item.new, and then we'll just insert that item ID in that item, and then we'll return the item ID. So again, like becomes like way simple here. This. Perfect. Format this. Great. Okay, so now those two are super simple. Let's go to the next one. Get available items. Should be straightforward as well. So just give that items instead of with items. It'll need access to the state. I think this actually doesn't need. So just for people who aren't familiar with Rust, this is a reference. So it's basically borrowing the ability to do something with the state and then returning it when it's done. And if it's just an and, then it means it can read it, but it can't write to it. If it's an and mute, then it can read it and write to it. So here, this just needs the ability to read from it. And we get rid of the with state. And so we're going to go through the state. We're going to get the items. We get the values in there. And we wanted to filter them for where their expiration is after now. So I think that's a function we can pull out. Eventually, we'll probably be able to delete this. But I'm just going to copy this for now, just so we can. And then I think we could probably. I need this, but let's see. So now this is do dot. Oh, so first thing I'm going to do is, again, I just Rust is very good about encapsulation, but at least here I don't want to necessarily have the encapsulation. So let's try deadline. I'm just going to make this public. And then item as well. These fields public. I could push more of this logic into methods on here, but right now. Oops. No. All right. Well, first I need some time. Okay. So then we need to be able to clone items. So that's fine. It's no problem. And we need to be able to clone expirations. Okay. So now one is compiling, and let's just kind of review it. So we're saying we're going to get all the items. We're going to filter them for the ones where the haven't already expired, and we're going to return them. So that seems fine. I think we have maybe two more to do. Let's see. So list. Yeah, we need bid and close auction. So let's grab bid. So this is going to take a bidder ID. and an item ID and a price, and it's going to return a bid result. And we're going to be able, we need to be able to work with state. Get rid of this. Width. Okay, and now we see we get some advantage of this because we don't even, here we were like getting the bidder ID and item ID, but we already have them. Those are passed in, so we don't need that. So now our logic is essentially, we say, look in the winning bids and see if there is a high bidder already. If no one's bid, then we insert ourselves. And then I think this is another issue of, again, I just need to make these public. So let me find my bid result. Okay. Okay, so now if there is no high bidder, I insert myself and I'm successful. Otherwise, I know there is a value in there. I could also do this by pattern matching, but at least right now, so this. I'm going to get the winning price. If my price is above it, then I add myself and I'm a success. And otherwise, I fail. And right now, we could make this error message better, but that seems like a fine starting point. And then the final one is closing the auction. So this will now just return a normal bidder ID. This again is going to need access to the state. Get this. Bidder ID. And so now, again, we can look. Okay, so here, one thing I'm noticing is this is an item ID that's a string. That's probably actually not what we want here. So this is another case we probably want to make a change to the WIT file. So let me go down to my WIT file. And yeah, see this should probably be an item ID. And hopefully this is giving a sense of also how you can kind of go back and forth between the WIT file and your code. And it's like protobuf where you update the protobuf, you need to update your code that's implementing that interface. So this is now going to be a WIT item ID. And then okay. Now we are almost all set here. Oh. So notice here I did cargo check versus cargo component check. That is an easy mistake to make, but then it's not going to know about all your types. So, okay. So now I'm all compiling here. I've got all my logic except this one, which I'm ready to do now. So this is going to be an item ID. And so I don't need to then create it. So let's look at this. So I'm going to look at the winning bid. There is no winning bidder, then can't close the auction. Otherwise, I'm going to look at the winning bidder. I don't need to do this because it's already a winning bid. I'm going to remove this item, and then I'm going to return the bidder ID. And then I'm going to need to look at, I think I used that. Here, let's see. Don't want to turn a reference to it. And then winning bids. Where did I use winning bids here? Nope. What am I doing? So I'm borrowing winning bids here. Let's see. Okay, perfect. And now that this is extracted out, we can also see there's a little bit of an issue here that right now you can close the auction anytime versus maybe you should only be able to close the auction when it's done, but maybe you won't be able to close it early, or maybe only like the one who the person created should call it. Maybe we need some authentication here. So there's some things we can think about here, but I think right now let's just finish this refactoring and we can note that as something to come back to. So now that I've got all these methods, first thing I'm going to do is I'm going to remember to make them public here so that I can call them. And we could use some more specific visibility modifiers if we wanted, but right now I'm just going to make them public here because really this is accessible to anything with my code. And so now what I want to do is I want to actually refactor this to use my new methods. So the first thing I'm going to do is I'm going to take this thing that's called state, and I'm going to rename it to, just like everything else, I'm going to call this width state. And maybe width isn't quite the, maybe call this WASM state or something. I'm going to call this width state here. I'm just going to basically change all these methods to be that. And there weren't that many of them, so there we go. Component check. And now I'm going to do kind of the final like big bang here, where I'm basically going to replace this state with the one that I had, and each of these implementations with the one that I had. So we won't be compiling for a little while, but then we'll be done with this. So now my struct width state is just going to have one state thing inside it. That's just a lazy of my state. And my initial one, oops, is just going to have one thing. And it's going to be a state new. And that's a good thing. I'm going to go over here. I'm going to go to my state. And I'll create a new one that just starts out with all those things being empty. And I'm also going to need to import so I'm going to do use model and bring in everything from the model. Okay. So now I've got my new state here. And then I think I can refactor this to have us just use our new state here. Okay, and so now let's go through these. So I'm going to initially just, oops, mark all these as unimplemented, just so I can kind of be compiling as I go. Okay, so now I'm compiling. I'll just double check that for myself. And now I just need to implement these. And so let's try doing one of these. So this register bidder now. So now I'm going to do my width state. I'm going to keep that. But now this could just be auction logic register bidder. And then I think this is not giving me back my right type here, because this is going to be bidder ID equal that, right? And this bidder ID, if I try to return this, this is now not quite the right type, because this is my internal bidder ID, but now I can just take advantage of that nice conversion functionality I implemented before. And I need a semicolon here. And this can actually even be simpler than this. So this could just be that. So now there's basically no logic going on here. I'm just kind of delegating here, and this thing's taking care of all the conversion for me. So let's do the same thing here, and I'll just grab this just to at least not repeat the with state stuff. So this could just be boom. Let's see how well Copilot can do with these last few. Right. Right, so we're going to again call our get auction, and then all we're doing is we're just mapping over each one, and we're converting that back into one of these bid items. All right, and then all we got to do is we can just remove some unused stuff. So we don't need this. We don't need this. We don't need this now function here. Don't need the time here. Oh yeah, well, that's fine. We may use those in the future, but that's fine. Okay, so there we go. And so now if we come back and we look at our code here, now there's almost nothing going on that isn't just like the basic boilerplate, right? We've got our little global state, we've got our helper method to access the global state, and each of these methods is just calling into our business logic here, just doing the actual logic and then converting back and forth. And with those Rust types, I mean, I agree with that. I mean, yours kind of be nice to automatically derive them, but even putting that aside, just having them automatically derived, it's really simple to do this. And so I think this is a lot cleaner. I'm going to take a second here just to check on messages, and then we'll go on. Let's see. So there's a question about winning the .map. Yeah, I mean, I think sometimes when you live code things, you you quickly do something. So you're saying basically here, yeah. I mean, clearly, if none, some, yeah, we could do that refactoring. So sure, we could either match on it or we could map it. I think maybe I'll leave this as is just right now in the interest of time, because I think we may do other refactorings here. But yeah, clearly. Okay, so summit where we've been. So I think we have finished this refactoring of that data model. Hopefully we maybe learned a little bit about Rust. I think our code is definitely cleaner now, and we're also set up to do other things. Like now you can see this code as well as this code doesn't do anything with those WIT types. And so these could potentially be moved to even a separate project within this workspace. And then we could write tests for these things and just use cargo task forward and not have any issues there. The other thing that I want to talk about, and I think with time, I'll just kind of give the overview of, and we'll kind of save for like doing next time, is this idea of moving from just having one worker to having multiple workers. And while I'm talking about that, I'm also looking. I see Yuri is typing, so I'll be on the lookout for him. But I think the idea here, yes. So Yuri, I think that's the other thing I was saying to you before when you were originally saying that you could derive the conversions. Yeah. So I think what you could imagine, and I don't think you quite do it the way I have it set up here, but you could imagine this auction logic thing. Instead of, this is right now not very object oriented, but this could be more object oriented, where like this was just like an interface that had these as methods on it. And yeah, you could have something like derive wit, and you could potentially create the wit file from that. There's a little bit of like, I think that'd be great for Rust. And I think one of the things we're thinking about a little bit is how we want to balance developing things that are great for one language versus having things that are great for all languages. Because one of the things that actually just got added based on some of Daniel's work is you can write stuff with Python now and have that work with Golem. So I think maybe we can do another week where we do like the same example, or another one with Python. And I have a feeling we'd see some very different things, because like all this state stuff wouldn't exist, and you'd see me making silly type errors and things like that. So there's a balance there of like adding deeper support for specific languages versus adding tools like the way we've done it now essentially works for any language. So I imagine we'll eventually be doing both, but that's just another thing to think about there. Okay, so we're already at over an hour, so I think I'm just going to give an overview of this, and we'll save the rest for next time. But the idea here is right now we just have this one auction app. And so that's fine for us, like having a little demo thing, and we could deploy this, right? And like, yeah, I could submit a couple of like bids on things. But we can imagine if we're really at a large scale, this is having one worker that's servicing all of this isn't really going to work. And so what I want us to move to is this idea that we have, let's say we think about having two types of workers, right? So one we could call the auction registry, and the other we could call an individual auction worker. And so the idea would be that we'll kind of split the states in here. We'll shard it, you could say, if you want to use that word technical term. And essentially this main auction app is just going to be responsible for like keeping the list of all the auctions that exist. And so what it's going to do, and then there's going to be a separate worker for every auction. So if there are a million auctions going on, there are going to be a million different workers for them. And that way, if you're interacting with a particular auction, you just interact with that auction. And so you could imagine if we like think about kind of the eBay version of this, there's, if you kind of go to the home page, right, that's interacting with the auction registry, and it's maintaining this internal state that's just saying like, hey, I got 5,000 auctions, active auctions right now, and here's what they are. And I think for us, it'll probably initially just list them, but we can imagine maybe there's some way to like search them or do something like that. And then if you're interested in any of them, it basically just maintains this mapping from each of these auctions to their, maybe like a description of them, to a identifier of the worker that's actually responsible for the auction. And then all this functionality specific to an auction of like bidding on one, or checking on the status of one, or closing on one, those are going to become methods on the auction worker. And so what we'll end up having is we'll have more than one WIT file. Well, essentially, we could imagine we'll have potentially an auction registry WIT and a auction worker WIT. And we may have different sub-projects here where we could imagine if we were a larger team, right, we'd like divide and conquer a little bit. And someone will be working on the auction registry and someone will be working on the auction worker. So each of those will have their own WIT file, just like if you had different internal microservices communicating with each other, each of them would have a protobuf file that specifies how they can be interacted with. And then initially, the way we're actually going to do that interaction is just going to be using the REST API, which already exists. That's not the most efficient way. It's also, I think, as we'll find, not going to be like, it's going to require a little bit of work to do, just we actually have to manually do those calls. So in the future, there's going to be a Golem runtime API that's going to make it easier to do that, but that doesn't exist yet. So I think that may be one where we're like a little bit ahead of the features that exist, and then we can kind of catch up to that. But this is going to make things a lot more scalable. And then I think what eventually we're also going to be interested in doing is actually having, and maybe I'll call this now, and then I'll call maybe in near future, I'll say. Third worker for each request. And so you could imagine right now, with just these two, we've got kind of the equivalent of like a backend, right? If this was all we had, we could imagine we could use whatever web framework we wanted to, and we could have a like front end that like, right, had like nice user interface we wanted, and when you do things like it calls these particular things. But with just these two, we don't really have functionality for kind of a user-facing application, right? We just have the backend where like you call one of these things and all it's going to give you, well, first you got to call this like particular like Golem API that you want to use, but you don't want to expose to your end user. And you're just going to get back some like text or some JSON or something. And so I think what we're going to get to, and we're definitely going to need some more support from our team here at Golem to let us do this, is to basically let us build a full stack application. And so the third worker, you'd have a worker respond for each web request that came in, and it would interact with the registry and the auction worker. It would get the data that it needed, and it would have the logic for how to take that request and potentially respond back with like a fully rendered page that the user could interact with. So that's where we're going. Definitely some work to get there, but hopefully today was like helpful in taking one step in the journey. Just looking at some questions here. So Juan says this is similar design to what you could do with actors. And yeah, so I think another one word you could describe for what we call as workers here is actors. I think actors like a little bit specific to particular Scala or maybe Erlang or stuff. So I'm not sure it's like the best word overall. And I'm generally trying to talk about them as workers. But yeah, if you come from that background, actors is a good analogy that you could do there. Right now, they're not built-in supervision strategies for them. You could definitely do that, right? Even here, you could imagine. I mean, maybe the auction registry. There's you deploy your auction registry because you want to sell whiskey or you want to sell whatever, and maybe part of its logic is it has some kind of like shutdown of like, hey, I'm out of the business. I'm done selling whiskey, and maybe it has some logic that at that point it terminates. It tells all these workers that they should stop what they're doing. So that could definitely be a possibility. I think we have to see a little bit how much that makes sense versus if you think about like cloud applications, right? They have their own management console, which we eventually want to have. So I'm not sure how much that kind of management console use case is going to supplant that, or people will just do that themselves. But that supervision is definitely a relevant analogy and something we could look at. And then, yeah, you could generate the HTML in the back end. Yeah, I think that's actually something that Terry had raised with our team and something that we are working on. So yeah, I mean, I think that would be the goal. That what I'd really like is when we're kind of done with this section, which I'm sure we'll take breaks in between, but maybe a couple months from now, that really there is some website you go to of maybe we'll get some domain that'll be fun for us. But you go to whiskeyauction.com and you see some fake pictures we put up here, and you can click on some things and interact with them. And maybe we'll need some maybe we'll need to bring in some friends here who have more front end skills so that things don't look as ugly as if I was just doing the front end myself. But that's the goal, that really this should be everything that you need with functionality that exists or functionality that's coming. Okay, so we're at an hour and 15 here. So I think it's probably a good time to call it. I hope this has been helpful for everyone. I know it's always fun for me to spend time with all of you. So yeah, have a wonderful rest of your day and a wonderful weekend.